Hello, ma'am.
Good evening, sir.
Yes, ma'am.
Sir, you can join. You can continue, sir.
Good evening, sir.
Yeah, good evening. Good evening.
Good evening, sir.
Yeah. Good evening, man. Akhil, you were there yesterday?
Yes, sir.
Akhil, you were there yesterday?
Yes, sir.
Okay. All right, we'll start. Or someone else joining? Ajay, are you there?
No, sir, you can start. Sorry.
Okay. Law of mass action and rate constant. We discussed about law of mass action yesterday. I don't know how many people remember, but anyways, we will learn the law of mass action and rate constant. Now assume a reaction, A moles of A plus B moles of B, giving you C moles of C and D moles of D. This is the reaction. Now A and B, this is called as reactants, and C and D will be called as products. And the small letter A, small letter B, small letter C, and small letter D are the coefficients, stoichiometric coefficients. Now, this law of mass action is proposed by two scientists. One is called as Guldberg, Guldberg, Guldberg. The other one is Waage, Waage, Waage. So these two people proposed the law of mass action. So what is this law of mass action? Yesterday, I clearly mentioned law of mass action. The condition is constant temperature. At constant temperature, rate of a reaction is directly proportional to product of molar concentrations of the reactants. So whatever we write it in the square bracket, it means it is molar concentration. Now, the reactants are A and B here. So I've written the concentration of A into concentration of B, whose coefficients are raised to their power. This is the mathematical representation of the law of mass action. What is law of mass action? At constant temperature, rate of a reaction is directly proportional to product of the molar concentrations of the reactants whose coefficients are raised to their power. Clearly from the law of mass action, we understand the speed of the reaction or the rate of a reaction depends only on the concentration of the reactants. It does not depend on the concentration of the product. It depends only on the concentration of the reactants. Now, what's the definition for law of mass action? We can define law of mass action as, okay, at constant temperature, the speed of the reaction, the rate of the reaction, the velocity of the reaction is directly proportional to molar concentrations of the reactants whose coefficients are raised to their power. Now, if you remove this proportionality sign, we have to give a proportionality constant. That proportionality constant, what we give is represented as K. This proportionality constant, K, is called as the rate constant. K is called as the rate constant. Now, how do you define a rate constant? In order to define a rate constant, we can write at or when we can write like this: when concentrations of the reactants are unity, when the concentration of the reactants, what is the concentration here? A. And what is the concentration here? B. When the concentrations of the reactants are unity. When I say unity, it is 1 molar. When the concentration of the reactants are unity or 1 molar, what happens? R becomes equal to what? K into 1 to the power A and B 1 to the power what? B. So what's happening now? Now R will become equal to what? K. The rate of a reaction becomes equal to rate constant of a reaction when the concentrations of the reactants are taken as unity. Did you understand this so far?
Yes, sir.
Did you follow? What is law of mass action? Law of mass action states that at constant temperature, rate of reaction is directly proportional to product. Product means multiplication. Product of molar concentrations or the active masses of the reactants whose coefficients are raised to their power. Now, if you remove the proportionality sign, we have to give a proportionality constant, and that proportionality constant, what we're giving is K. And this K is called as rate constant. It is also called as specific reaction constant. It is also called as specific reaction constant. Now, when the concentration of reactants are taken as unity, when the concentration of the reactants here, A and B, are taken as unity, as 1 molar, what happens? R becomes equal to K. So rate constant reaction becomes equal to rate of reaction when the concentrations of the reactants are taken as unity. Now, the value of the rate constant depends on nature of the reaction, temperature, and constant. It is independent of concentration. See, this rate constant depends on the nature of the reactant, concentration of the reactant. Remember, K value does not depend on concentration of the reactant. Now, what's the unit for rate constant? Unit for rate constant is given by liter per mole to the power n minus 1 into per second, or we can write it as mole per liter to the power 1 minus n per second. What is this n? N stands for order of the reaction. We will learn what is order of the reaction in few minutes time today. Now, you understand what is the unit for, general unit for rate constant. It is mole per liter, the power 1 minus n per second. This is the unit for the rate constant of a reaction. This n stands for order of the reaction. We will learn what is order of the reaction in a few minutes time. Did you understand so far? Law of mass action can be asked for 2 marks. Can you define what is law of mass action? And they can ask you what is rate constant. Mathematical representation you have to give, and also you have to write it in statements. Statement, let's see the statement here. The rate at which the substance reacts is directly proportional. Rate at which the substance reacts. That means the speed at which the reaction takes place is directly proportional to its active mass. Active mass is also called as molar concentration. Active mass is also called as molar concentration. And the rate at which the reaction proceeds is proportional to the product of active masses of the reacting substances. Product of the active mass of the reacting substances. All right. Now coming to the next part of the question, next part of the topic, rate law, molecularity and order of the reaction. Now, what is this molecularity and order of the reaction? Molecularity, see, this is very important question for the 12th standard exam. All right. You should know what is molecularity and order of the reaction. Now, what is this molecularity? Now, before we get into the definition of molecularity, we should understand reaction is
Excuse me, sir.
not taking place
Sir,
always
excuse
in
me,
one
sir.
step. So if a reaction, yes, ma'am. Hello.
Excuse me, sir.
Yeah, ma'am.
You're
Tell
not
me,
audible,
ma'am.
sir.
Yeah. How, ma'am?
Your voice is breaking, sir.
audible?
Yes, sir. Now you are audible.
Now am I audible?
No, sir. Sir, can you please tell that again? What did you say?
Molecularity and order of the reaction. That is why students, please. No, I didn't tell anything. No. Hello, ma'am, can you hear me? Hello.
Sir, your voice is breaking, sir.
Now is it clear, ma'am? Now is it clear?
Yes, sir.
Hello. Students, is it clear?
Yes.
Yes, sir.
Yeah, you have to keep talking to me. Only then I will know whether I'm audible or not. This is not one-on-one. It's on the net. We don't know what's happening in the background. That is why I repeatedly keep asking you to participate in the class. All right, students, are you able to hear me now?
Yes,
Can you
sir.
hear me now?
Yes, sir.
Ajay?
Yes, sir. I can hear you, sir.
Now, reaction is not taking place always in one step. So when the reaction takes place, in more than one step, when the reaction takes place more than one step, then it is called as a multi-step reaction. It is called as a multi-step reaction. The reaction takes place in more than one step, then it is called as a multi-step reaction. In a multi-step reaction, all the steps of the reaction will not be of the same speed. All the reaction will not be of the same speed. Some of the reaction steps will be slower and some of the step of reaction will be faster. Now assume A plus B giving you, this is the product, assume. Now what happens is A plus B gives you an intermediate compound AC, and this AC again react with B, then gives you product. This is step 1 and this is step 2, assume. Now this step 1 and step 2 will not be of the same speed. One of the step of the reaction will be slow, the other step of the reaction will be fast. The slow step of the reaction is called as rate determining step. The slow step of the reaction is called as rate determining step. Or this slow step of the reaction is also called as elementary reaction. It's also called as elementary reaction step, or it is also called as elementary reaction. It's also called as elementary reaction. Students, can you hear me?
Yes, sir.
Yes,
Yeah.
sir.
Now, the rate determining step is also called as elementary reaction. Now, we are talking about something called as molecularity and order of the reaction. Now, I told you a reaction need not be always in one step. The reaction can take place in more than one step. When the reaction takes place in more than one step, it is called as a multi-step reaction. In a multi-step reaction, if the reaction, which is the slowest step, that step reaction is called as a rate determining step. And that step is otherwise also called as elementary reaction. Slow step of the reaction is called as what? Rate determining step, or it is also called as elementary reaction. Now, what is this molecularity? Now, you people answer me this question. Now, I'm writing this. Can I firstly call this as a reaction? Can I firstly call this as a reaction? Please tell me, don't hesitate. You tell whatever you feel like. Can I call this as a reaction? Can a reaction take place without the reactants?
No, sir.
Then this cannot be called as what? A
So yes,
reaction. So for a reaction to take place, we need to have what? A reactants. This reactants will react to give you what? The product. Now, what is this molecularity? Firstly, remember molecularity is determined theoretically by completely balanced equation. Now, molecularity is determined theoretically by completely balanced equation. Now, what is this molecularity? Now, we understood that without a reactants, the reaction cannot take place. Without a reactants, product cannot be formed. Now, what is this molecularity definition? Molecularity is defined as minimum number of reactant molecules taking part in the slow step, or the elementary reaction is called as molecularity. What is molecularity? I told you, a reaction need not be in one step. A reaction can take place in more than one step. When the reaction takes place in more than one step, the slow step of the reaction is called as a rate determining step, and that is also called as elementary reaction, I told you. In the slow step of the reaction, how many molecules is taking part in the reaction is called as molecularity. Did you understand the definition of molecularity? Molecularity is defined as minimum number of reactant molecules taking part in the slow step of the reaction, or the elementary reaction is called as molecularity. You can see here, molecularity is defined as sum of the number of molecules of reactant involved in a balanced chemical equation. Molecularity of a complete reaction has no significance, and overall kinetics of the reaction depends upon the rate determining step. The slowest step is the rate determining step. This was proposed by Van 't Hoff. So this definition, this is a lengthier definition. Now we can minimize, or we can simplify and tell the definition of molecularity to be minimum number of reactant molecules taking part in the slow step of the reaction, or the elementary reaction. How do you determine molecularity? Molecularity is determined theoretically by completely balanced equation. You can see here. Here also they have given it is completely balanced equation. So molecularity is determined theoretically by a completely balanced equation. You followed with this definition? Very important question this is. What is molecularity? Minimum number of reactant molecules taking part in the slow step of the reaction, or the elementary reaction is called as molecularity. Is it clear, students?
yes, sir.
Now, how do you determine molecularity? How do you determine molecularity? It is determined.
So by finding the number of reactant molecules which is taking part in the slow step or elementary reaction.
How do you find? How do you find? It is determined what? Theoretically. It is not done by an experiment. It is done by what? The knowledge of the reaction. So it is called as what? It is determined theoretically by what? Completely balanced equation. Did you follow now?
Yes, sir.
Yes, sir.
Yes. Now this molecularity is classified into many. The first one will be called as unimolecular reaction. Uni stands for one. Molecular means a reaction in which only one molecule is taking part is called as unimolecular reaction. Now for an example, if I take PCl5, this is phosphorus pentachloride. This phosphorus pentachloride on heating, this phosphorus pentachloride will decompose to form phosphorus trichloride and gives you chlorine. Now when I say heating, the energy has to be supplied. That itself is an indication the reaction is a slow step of the reaction. In the slow step of the reaction, How many reactant molecules taking part? How many reactant molecules taking part? How many molecules is this? PCl5 is how many molecules?
Sir, one, sir.
One. So therefore, we call the molecularity of the reaction is what? One. When the molecularity of the reaction is one, it's called as unimolecular reaction. What is unimolecular reaction? A reaction in which how many molecules take part in the reaction? How many reactant molecules? One reactant molecules take part in the reaction. Therefore, it's called as what? A unimolecular reaction, or the reaction's molecularity of the reaction is two. One molecularity of the reaction is one. Did you follow the definition?
Yes, sir.
Yes, sir.
Bimolecular reaction. Now, when we say bimolecular reaction, I want you to define what is bimolecular reaction. N2 plus O2, when you heat, we get NO, 2NO. This is the reaction. How many reactant molecules are taking part in the reaction? It's a slow step of the reaction. It's a one step of the reaction. This is also one step. This is also one step. How many reactant molecules are taking part? How many reactant molecules? Look at the reaction and tell me how many reactant molecules. One nitrogen and one?
Sir, one and one, sir. Two, sir, totally.
Two, sir.
Totally, two. Since two molecules are taking part, we call this as what? A bimolecular reaction. Now, firstly, you observe these two equations and tell me whether the reaction is balanced or not. Reaction is balanced or not?
Yes,
Reaction
sir.
is
So
balanced?
balanced,
Yes.
sir.
Yes. So that's what I told you. Molecularity is determined theoretically by a completely balanced equation. So these two are completely balanced equations. Now, in this equation, how many number of reactant molecules are taking part? Two. Therefore, we call the molecularity of this reaction to be two. When the molecularity of this reaction is two, it's called as a bimolecular reaction. So if they ask you what is molecularity or what is unimolecular, bimolecular, you have to write a statement and you have to give an example also. Now the third, what we have is, it's not tri, it's called as termolecular, TER, termolecular reaction. It's not called as trimolecular, it's called as termolecular reaction. Now when we say termolecular reaction, just observe this. 2NO plus O2 giving you 2NO2. This also is a slow step, one step reaction, and it's happening slowly because it requires heat. Now tell me how many reactant molecules are taking part? How many reactant molecules are taking part? How many reactant molecules are taking part? Huh?
Sir, three, sir, totally.
Two nitric oxide and one oxygen. Totally it will be what? 2 plus 1. So therefore it will be how much? 3.
Three, sir.
Since three molecules are taking part in the reaction, its molecularity is 3 and it is called as a termolecular reaction. It's called as what? A termolecular reaction. Did you understand? A reaction whose molecularity is 3, or a reaction in which 3 molecules take part in the reaction, is called as a termolecular reaction. It's called as what? A termolecular reaction. Followed?
Yes, sir.
Yes, sir.
Now you tell me, 2 questions I'm asking you. Can molecularity be 0?
No, sir.
Can a reaction take place? No, molecularity
No,
cannot
sir,
be
no,
0.
sir. The reaction was
Molecularity
hopeless.
cannot be 0. Correct. Good. The second question is, now we have learned 3 examples, which is on the screen. Now you answer me this question. Can a reaction be in fraction? Can a reaction be in fraction? Can a reaction be in fraction? Can I
Sir,
have
no,
molecularity of
sir, no, sir, no, sir.
1 by 4? Did I take
No,
any?
sir.
No. Molecularity cannot be a fraction. Molecularity cannot be 0 also. Remember, we have to learn the differences later. That's why I'm telling you. Firstly, the molecularity is defined as minimum number of reactant molecules taking part in the elementary reaction or slow step of the reaction. The second point is, the molecularity is determined theoretically by a completely balanced equation. And the classification of molecularity is classified as unimolecular, bimolecular, and also termolecular, TER. It is not tri, it is TER. So a reaction in which only one molecule is taking part is called as unimolecular reaction. A reaction in which two molecules are taking part will be called as a bimolecular reaction. And the reaction which takes place with three molecules will be called as a termolecular reaction. Now, the total number of molecules or atoms whose concentration determine the rate of reaction is known as order of the reaction. This is not the right definition. We will learn what is the order of the reaction in a few minutes' time. Now, all right, here you can see the multi-step reaction. This is the overall reaction. Now, okay, if you have understood what is molecularity, now just observe these reactions. This is observe these reactions. This is the overall reaction. This is the overall reaction. Now, 3 steps. It takes place in 3 steps. Now, which is the rate determining step here? Which is the slow step of the reaction here? Which is the slow step? The second step is the slow step of the reaction. You can see it's written. In the second step, how many molecules are taking part? How many molecules are taking part? This is the rate determining step. How many molecules is taking part? How many is taking part? 1 plus 1, how many?
So 2, sir.
Therefore, the molecularity of this reaction will be what? 2. Now, if you observe here, it will be 2 moles of A and 3 moles of E. Totally 5 molecules are taking part. As per the overall reaction, you can see how many molecules are taking part. 5, 2 plus 3. But the first step is fast, and the third step is also fast. The second step is a slow step, and it's a rate determining step. In the second step, how many molecules are taking part? 2. Therefore, the molecularity of this particular reaction will be 2 and not 5. Did you understand why?
Yes, sir.
This is called as rate determining step. The rate determining step, we have only 2 molecules. Therefore, the molecularity of this reaction is 2. See, this is called as mechanism. Kinetic deals not only with the speed, but also with the mechanism of the reaction. You can see this is the mechanism of the reaction. In the mechanism, the slowest step of the reaction, 2 molecules are taking part. Therefore, the molecularity of this reaction is 2. All right. See, a molecularity of reaction can't be 0. It can't be negative. It can't be a fraction. All right. We will learn what is order of the reaction in detail. I'm looking for the space. Yes, the space is here. Now, order of the reaction. See, order of the reaction is important. A lot of interesting numericals we can work, complicated numericals, interesting numericals we can work on order of the reactions. Anyway, we will learn what is order of the reaction numericals. We will learn later. Now, let's see what is the definition for order of the reaction. Order of the reaction. Now, for an example, if I take a reaction A plus B, giving you C plus D, this is the reaction. Now, as per the law of mass action, Goldberg's law of mass action, rate of a reaction is directly proportional to concentration of A into concentration of B. What is the coefficients of A and B? What is the coefficients of A and B? What is the coefficients of A and B?
So 1, sir.
If I don't write it 1, it's okay, na? Power, it's
Yes,
also. Yes. Now, I am writing the power for A as X and power for B as Y. I am writing it. What is this X and Y? We will learn. Now, this is the reaction. Now, the molecule, the number of the coefficient of A is 1 and the coefficient of B is also 1. So, this is the rate equation. Now, firstly, the definition for order we'll understand. What is order of a reaction? Order is defined as sum of the powers of the concentration terms, sum of the powers of the concentration terms in an experimentally determined rate equation. An experimentally determined rate equation. Now you see, order is determined experimentally. Now, if you observe this theoretically, the coefficient of A and coefficient of B is 1. Therefore, I should have written it as 1 and 1, not X and Y. But when you determine it experimentally, the power with respect to A is marked as X and power with B to B is marked as Y. Now, the order of the reaction is sum of the powers. So order is represented as small letter n. This order of this reaction is defined as X plus Y. Order is defined as what? X plus Y. What is this order of the reaction? We will learn in further detail, further chapter, how we can determine order of the reaction, methods of determining order of the reaction, all that. It's not there in your syllabus, but we will discuss for understanding. Now, what's the definition for order of a reaction? Order of a reaction is defined as sum of the powers of the concentration terms in an experimentally determined rate equation. See, this equation is experimentally determined. If I write it theoretically based on law of mass action, I would have written it as rate is directly proportional to concentration of A into concentration of B. This is theoretically. Theoretically, we understand the coefficient of A is 1 and B is 1. Therefore, if I don't write 1 or if I write 1, it makes no difference. This is the rate equation theoretically. But from this theoretical rate equation or from law of mass action, we cannot determine the order of the reaction. We cannot determine the order of the reaction. Therefore, we have to determine the order of the reaction experimentally. So when you determine experimentally, some of the powers of the concentration terms in an experimentally determined rate equation is called as what? The order of the reaction. Did you follow this?
Yes, sir.
Others?
Yes, sir.
Now we have different types of orders to be learned. Now, when we say different types of orders to be learned, the first one is zero order reaction. The first one is zero order reaction. So we understand by the name itself, the order can be zero. Order can be zero. Now, for an example, now on the surface of the lake water or pond or something, we will have hydrogen gas as well as what? Chlorine gas. Now, this hydrogen and chlorine will react in the presence of sunlight to form HCl. This is called as photochemical reaction. This is called as photochemical reaction. Second, when you pass ammonia gas on the surface of gold at high temperature, I think it is 773 Kelvin. The temperature is 773 Kelvin. Let's see, I don't remember. All right, what high temperature? What happens is this ammonia will decompose to form nitrogen gas and gives you hydrogen gas. It will react or decompose to give you nitrogen and hydrogen gas. Now, what is the order with respect to first equation? And this order with respect to second equation, what is that you expect? What is that you learn? Tell me. This is at high temperature, it's 1130 Kelvin, very high temperature. Tell me, what is this order? Now I say the order with respect to the first equation. Experimentally, when I determine the rate equation, the concentration of hydrogen to the power 0 and chlorine concentration to the power 0. So therefore, the order of this reaction is 0. And here also, if I write the rate equation, I write the concentration of ammonia. The coefficient is 2. I should write it as 2 here, but I write it 0. Therefore, this is also an example for zero order reaction. What is this zero order reaction? Firstly, you should remember, is it possible for us to measure the amount of hydrogen and chlorine present on the surface of a lake or a pond? First question. Second one, irrespective of the amount of hydrogen and chlorine present, They will react to give HCl. Now, for decomposition of ammonia also, we don't require the specific amount of ammonia. Any amount of ammonia you take, when you pass over gold or platinum catalyst at 1130 Kelvin, this ammonia will decompose to give nitrogen and hydrogen. That means both the reaction does not depend on the concentration of the reactants. That is why we have written the order with respect to hydrogen is 0 and order with respect to chlorine is 0. And also for the second equation, the order with respect to ammonia is 0. What is the zero order reaction? A reaction whose rate is directly proportional to zeroth power of the concentration terms. Zeroth power of the concentration terms, TERM, terms is called as a zero order reaction. Or simply we can say a reaction whose rate is independent of initial concentration. We can write a reaction, otherwise we can define a reaction whose rate is independent of initial concentration of the reactants is called as the zero order reaction. So it means for a zero order reaction, will not depend on the concentration of the reactants. Those kind of reactions are called a zero order reaction. It's a 2-mark question for your 12th standard. Okay, but a lot of competitive exam questions are there. We have to learn based on this order. We will learn the other order of the reactions also in now. Did you understand what is zero order reaction? Did you follow? If you have understood zero order reaction, we can go for the other order of reaction very quickly.
Yes, sir. Understood.
Yes, sir, understood, sir.
A zero order reaction is a reaction whose rate is directly proportional to zeroth power. Now, as per the theoretical knowledge, the coefficient of hydrogen is 1, coefficient of chlorine is 1. So the order of the reaction should be 1 plus 1. Therefore, it should be 2. But here the order of the reaction is 0. Why? Because this reaction does not depend on the concentration of the reactant. Therefore, order with respect to the reactants are what? 0. Therefore, the net order of the reaction is also 0. Did you follow this?
Yes,
Yeah.
sir.
Yes, sir.
Now we will learn the first order reaction. What will be the definition for the first order reaction? I'll give you an example, then we will try to understand what is the first order reaction definition, all that. Now, firstly, you should remember order is determined experimentally. Order can be 0. It can be a whole number. It also can be a fraction. We will learn all that, fractional order reaction, all that now. Now, it's a first order reaction. What is this first order reaction? Now we will take an example. 2 moles of N2O5. When you heat, it decomposes to give nitrogen pentoxide. When you heat, it decomposes to give nitrogen dioxide and oxygen. This is the reaction. Now, what is this? Rate of a reaction is directly proportional to concentration of N2O5 to the power what? 2. This is theoretical. But when you perform an experiment to find the order of the reaction, the order of this reaction will be, or rate of a reaction will be directly proportional to the first power of the concentration terms. What is this first order reaction? A reaction whose rate is directly proportional to first power of the concentration terms. See, order is determined experimentally. With our knowledge, theoretical knowledge, if you see, the order should be what? 2, but it is not 2. Why? When you do an experiment, then you determine the rate of the reaction based on the experiment. The order with respect to the reactant remains what? 1. Therefore, it is reaction. A first order reaction order is 1. It is a first order reaction. Did you follow this? What is the first order reaction? A reaction whose rate is directly proportional to what power? First power of the concentration term is called as a first order reaction. Now, example you should remember. Now we will learn what is a second order reaction. What will be the definition for the second order reaction? What will be the definition for a second order reaction? What will be the definition for the second order reaction? A reaction whose rate is directly proportional to what power? What power? What power? I've written.
So second, sir.
Second power. Now just observe this. H2 plus I2 giving you 2HI. This is the reaction. Now the rate of a reaction experimentally when you determine, the order with respect to hydrogen remains 1. The order with respect to iodine also remains 1. Therefore, the overall order of the reaction is 1 plus 1. It is 2. Therefore, we define second order reaction to be a reaction whose rate is directly proportional to the second power of the concentration terms as what? A second order reaction. Clear?
Yes,
Yes,
sir.
sir.
Now the third order reaction definition you give quickly, let's see. What will be the third order definition? Third order definition. A reaction whose rate is
Sir, a
directly
reaction whose
proportional
rate is directly proportional to the third power of the
of the
concentration term.
concentration terms. Let's say third power of the concentration terms. One example we will learn. There are a number of examples. Third power. Now 2NO plus O2 giving you 2NO2. Now in the rate, in the experimentally determined rate equation, the order with respect to NO is 2 and order with respect to oxygen is 1. Therefore, the net order is, or the overall order of the reaction is 3. So what will be the definition for a third order reaction? A reaction whose rate is directly proportional to third power of the concentration terms is called as a third order reaction. So remember, order is determined experimentally. All right. Understood? Now, it is fractional ordered reaction. Fractional order. What will be the definition for fractional order reaction? A reaction whose rate is directly proportional to what?
So to fractional power of concentration terms.
Now you just observe the example. Acetaldehyde. Because acetaldehyde, when we heat it, it will decompose to form methane and giving you carbon monoxide. Carbon monoxide. Now, as per the theoretical knowledge, we understand rate is directly proportional to concentration of acetaldehyde to the power 1 because the coefficient is 1. We expect the order to be what? 1. We expect the order to be 1. But when we determine the order rate of reaction experimentally, the order with respect to acetaldehyde is 3/2. Now, when we say the order with acetaldehyde experimentally is what? 3/2. 3/2 is a fraction. 1.5 is a fraction. So those kind of reactions are called as fractional order reaction. What is fractional order reaction? A reaction whose rate is directly proportional to what power? The fractional power of the concentration terms is called as a fractional order reaction. Did you follow this?
Yes, sir.
Now they can ask you individually, define zero order reaction, or what is first order reaction, give an example, second order reaction example, fractional order reaction example, tertiary, third order reaction example. Please remember the definitions also. And we're going to learn 2 questions and then we'll try to stop. Let's see whether we are able to finish the 2 questions today, the other 2 questions. Today we've learned a lot of topic. but I hope you followed. The numericals we'll have to learn possibly in the next class based on this. Now, an important question, what we're going to learn is called as pseudo first order reaction. Pseudo first order reaction. Pseudo means false. False first order reaction. When I say false first order reaction, now we will take an example. What is the name of this molecule? Can you tell me what's the name of this molecule? The common name for this molecule is methyl acetate. The heading is acid catalyzed hydrolysis of methyl acetate. This is the heading. Acid catalyzed hydrolysis of methyl acetate. This is the heading. So this methyl acetate, when you hydrolyze, hydrolysis is water addition. In the presence of an acid, acid is represented as H plus. So what happens is, assume that the bond breaks here. Water, we can write it as OH and we can write it as H. So we get the product as acetic acid and we get methyl alcohol. This is the reaction. Now, as per the reaction, the rate is directly proportional to concentration of methyl acetate and concentration of water. Now, when you determine experimentally, the order with respect to methyl acetate is 1, the order with respect to water is 0. Why the order with respect to water is 0? For this hydrolysis, water is taken in large excess. When I say it is taken in large excess, only few molecules are taking part in the reaction. So water, the concentration of water is in large excess. How many molecules are taking part? Only few molecules are taking part. Therefore, I can say the concentration of water remains. Yes or no? We can say that the concentration of water remains almost what?
So the same, sir.
What we can say? Yeah, water, the concentration remains almost the same. When the concentration of water remains almost the same, the order with respect to water is 0. Therefore, we say the molecularity of this reaction is 2. How many molecules are taking part? 2 molecules. But order of the reaction is 1. So when 2 molecules are taking part, we expect the order to be 2. But here the order of the reaction is what? 1. Therefore, it is called as a false first order reaction. The order expected is 2, but it is 1. Therefore, it's called as false first order reaction, pseudo first order reaction. A reaction, this is important, a reaction whose molecularity is greater than 1, but a pseudo first order reaction. What is false first order reaction or pseudo first order reaction? A reaction whose molecularity is greater than 1, but the order of the reaction is 1. So here for this particular reaction, the expected order should be what? 2. But since the concentration of water is in excess, water concentration is what? Excess. Therefore, order with respect to water is what? 0. Did you follow this?
Yes, sir.
Yes, sir.
Yeah. Now we'll have to learn the last question based on order and molecularity. Now, what is the last question which is asked for 12th standard order and molecularity? The difference between order and molecularity. They can ask you, it's a regular question for 12th standard. Difference. What's the difference between order and molecularity? 1 minute. Difference between order and molecularity. All right. Difference between order and molecularity. Now we will take molecularity and we'll take order. Now, what is the first point? Molecularity is defined as what? Minimum number of reactant molecules taking part in the elementary reaction. The definition itself. But what is order of the reaction? Order of the reaction is defined as what? Sum of the powers of concentration terms in an experimentally determined rate equation. So order is defined as sum of powers of the concentration terms in an experimentally determined rate equation. The definition itself can be defined or given as what? The difference. Second, molecularity is determined theoretically by balanced equation. Balanced equation. Order is determined what? Determined what? How do you get determine order? Order is determined experiment.
So experimentally.
Yeah, third point. Molecularity can never be.
So fraction.
Yeah, never be 0 or a fraction. Order can be 0, a fraction, or what? A whole number. Molecularity is always what? A whole number. Always a whole number. So these are the three differences which you're supposed to know. All right. So between molecularity and order of the reaction. So we have dealt with the concept called as law of mass action, order and molecularity in detail. Now we have to learn how to determine the order of the reaction. So determination of order of the reaction is not in your syllabus, but methods of determination, see the difference is given here. The definition, theoretically, it's experimental determined. It has only integer value, whole number. Order can be fraction. Molecularity cannot be 0. Order can be 0. It provides no information. Molecularity provides no information about the reaction mechanism, but the order gives you the information about the mechanism. These are the difference between order and molecularity. So this is with respect to the examples for different order, molecularity, all that. All right, you can just go through. Rate constant also is given. All right, this we will do it in the next class. See, it's an example only, order and molecularity of some reaction. So what happened? So this examples you can go through. It will be there in the video and the recording. You can just see different types of or reaction, different order. See, the molecularity is given here and the order they have given here, all that, you know. So for different examples. And sorry, what happened? Okay. Next is rate constant. See, these formulas we have to derive. We will derive these formulas a little later in the next class, possibly in the next class. Methods of determining the order of the reaction. The first one is integration method. See, the system, the syllabus does not tell you to teach the procedure, but at least remember, the first one is integration method. We can determine the order by integration method. Second, we can determine it by the half-life method. We can determine the order of the reaction by half-life method. I didn't teach you what is half-life, all that. We'll have to learn later. And third, we can determine the order of the reaction by graphical method. And fourth, we can determine the order of the reaction by Oswald's isolation method. Oswald's isolation method. Four methods. One is integration method. The one is integration method. The second one is half-life method. Half-life method. Third is graphical method. And the fourth method is Oswald isolation method. So 4 methods we can determine the order of the reaction. In your syllabus, we don't have the procedures, or we don't have the syllabus to determine the order of the reaction. So in the syllabus only they have discussed or asked us to discuss what is order of the reaction. So remember this for competitive exams, methods of determining the order. One is integration method, the other one is half-life method, third is graphical method, the fourth is Oswald's isolation method. Okay, so anyways, the next part of the topic in the next class we will continue. Madam, I'll stop, ma'am.
Yes, sir. Thank you, sir.
Thank you,
Bye.
sir.